Hi, and welcome to this video on Booleans, where we start our deep dive looking at the Boolean data type in Python. Now, Booleans are an integer subclass, and so we'll cover that in detail in this video. The Bool class, and the Bool class is described in PEP 285. So if you're interested in that, you can do a search on the web for PEP 285, and it will show you kind of the thinking and the thought process and the rationale behind the Boolean type in Python. And it's really an interesting read. I suggest you take a look at that if you're interested. But we'll cover most of that in this video. So Python has a concrete Bool class that is used to represent Boolean values. Now the Bool class is a subclass of the int class. So the Bool class inherits from integers, which means that it possesses all the properties and the methods of integers, such as addition, subtraction, the div, the mod operators, and so on. And then it also adds a few of its own, like AND, OR, XOR. So you can actually test this, and there is a built-in method to Python called isSubclass that will check to see whether a Boolean, well, it will check to see whether a class is a subclass of another class. So you just pass in the two types that you're interested in. And in this case, well, it returns true, since Boolean is a subclass of int, right? It inherits from int. Now, two constants are defined in Python. They're called true and false, and they are instances of bool. So you can use the built-in method in Python called isInstance to check if a variable is an instance of some type. So in this case, true is an instance of bool. So this will return true, right? So it will actually return itself. But if we also look at this code here, isInstance true comma int, well, since Booleans are integers, the subclass of integers, well, that will also return true. Now, they are singleton objects. So what are singleton objects? We've covered that before, but just a quick reminder. So true is nothing more than a label that points to some object in memory that is of bool type, that lives at some memory address, and then has some internal value. And its internal value is an integer of value 1. And then false is the same thing. Basically, it's just an alias or a label that points to an object of type bool in memory at some memory address, which has an internal value of an int 0. So true is the same thing as the integer 1, and false is the integer 0. But of course, it's got a little bit more than just 1 and 0 as integers because they're Booleans, so they have some extra functionality. Now, using is and equals equals, if you remember from the earlier videos we had in the first section, is the identity operator that we can use to compare memory addresses, and equals equals compares more than numerical values. So true and false are singleton objects, which means that they retain their same memory address throughout the lifetime of the application. So true will be at some memory address when your application starts up, and it will stay at that memory address the entire time of the program. It will never change. Whenever you use true, it will always be at that memory address. And same thing with false. So when you're comparing a Boolean expression to true and false, you can use either the is operation or the equals equals operator. So either the identity or the equality operator. It doesn't matter which, it's actually completely equivalent. And that's only because true is a singleton object, and so is false. And of course, A has to be some kind of Boolean object. So it might be a Boolean expression, like 3 less than 4. Well, 3 less than 4 will return true, right? That will evaluate to true, and that true that gets returned from the expression 3 less than 4 is the same true as just the constant true, because it's a singleton object, and therefore there's only one instance of it throughout the lifetime of your code. Now, Boolean objects are also integer objects, since they just inherit from ints, so they can also just be interpreted as the integers 1 and 0. If we look at int of true, so we can actually cast true to an int, right? We can call the constructor of int and essentially cast true to an int. Well, we get a 1 back, which is what we expect, since true's internal value is an int of 1. And the same thing with false. If we cast false to an int, then we get 0. But, and this is really important to understand, true and 1 are not the same objects, right? They have the same value, but they are not the same objects. true lives at some memory address and 1 lives at some different memory address. They're not even the same types, right? True is Boolean, 1 is int. Yes, Booleans inherit from int, but they are still not the same object. So that's really important to understand, because what it means is that the ID of true, the memory address of true, is not the same as the memory address of 1. And the same thing goes with false and 0. They are not the same objects. The ID of false is not the same thing as the ID of 0. Which means that if you were to write something like this, true is 1, remember the is, the identity operator, checks the memory address. Well, that will return therefore false, because, well, they're not the same objects. They don't live at the same memory address. On the other hand, if you use the equality operator, true equals 1, that will return true, because it is true, right? True is equal to 1, but it is not 1. So a distinction that has to be made and that you have to remember. So now this whole thing can lead to kind of strange maybe behavior that you may not expect. And it's this whole thing with the polymorphism that comes into play. But you can write an expression like true greater than false. Now, I'm not saying that any of these expressions we're going to write here make a lot of sense, or that these are things you necessarily want to write in your code. Most of the time you don't. There are exceptions when it is useful, and we'll see that later when we look at things like list comprehensions and so on. But for now, these are probably, code samples that you might shy away from in your own code. But they do work. So true greater than false will return true. Well, because true is really 1 and false is also 0, right? So 1 is greater than 0. That is true. You can also write this 1 equals 2 equals false. Well, that, that kind of makes sense, right? That's a piece of code that, looks fine. What's going to happen? 1 equals 2 is false, right? 1 is not equal to 2. So we'll get a false result out of this expression here in the parentheses. And false equals false, well, we know that that is true. But another way you could have written this is this way. Is 1 equals 2 equals 0. So that one really looks weird now. I mean, this is kind of a weird syntax. But remember that 0 and false are kind of the same thing. False is just 0 with some extra functionality. So in this case, we'll also get true, because 1 equals 2 is false, which is 0, and 0 is equal to 0. So we get true. Now, the parentheses here are important, and we'll see that in an upcoming video when we look at chained operations in Python. But they are important here, and we'll explain why in a later section. So, in fact, any integer operation will also work with Booleans, addition, subtraction, the div, the mod, and all those things. So, for example, you could write true plus true plus true. that will return 3. Again, I don't necessarily propose that you should write things like this in your code. There are some actually use cases where this actually can be useful, but we'll see those later. You could also do this, true plus true plus true, parentheses, mod 2. Well, that's going to be 3 mod 2, which is going to be 1. You can also write minus true, negative true, which is just negative 1, right? So you can write these kinds of weird things, 100 times false. Well, false is 0, so 100 times 0 will return 0, right? So you can do all these kinds of weird things. Now, the Boolean constructor, right, it's just bool, and then we pass in a single parameter x, and the way it's defined is that it will return true, right, when x is true. So if you pass in true, or an expression that evaluates to true in this, it will return true. And if you pass in false, it will return false. So you might think that that's a pretty useless constructor if that's the only thing it can do, but not at all. And the reason why this is actually very useful is because every class in Python implements something called its truth value. And its truth value is basically saying and asking a class, if I were to ask you how you would describe yourself as a Boolean, what would you say? And each class implements that. And it says, well, if I'm in this kind of state, then I'm going to say I'm in a true state. And if I'm in this state, I'm in a false state. And that's basically how most of the classes, and even our own classes, our custom classes that we write, will also have that property. and we can actually define what that property should be and how it should behave. And we'll get into that in the section on object-oriented programming. But this is sometimes called the truth value of an object, or the truthiness is used also quite commonly to describe this. And basically it's just what is the truth value of an object. And we'll have an upcoming video that discusses that in a lot more detail. But integers have a truth value. Integers have this truthiness, and they do that according to a very simple rule, which is if the integer is 0, its truth value is false, right? And so we say that 0 is falsy because it has a truth value of false. And bool of x is true for any integer x other than 0. And so we would say in this case that x is truthy. 1 has a truth value of true. 2 has a truth value of true, and so on. And we'll check it, and see some examples of that. So bool of 0 is false, so 0 is falsy. Bool of 1 is true, 1 is truthy. 100 will also return true. -1 will also return true, so don't fall into that trap. Some languages will use -1 as false, not in Python. False is 0, and that's it. Everything else is true when you're talking about integers, right? So it's a very simple rule, and it's the truth value of integers. And in the next video, we'll take a look at how that actually works, okay? For now, let's just switch to some code and take a look at all this in action. So let's start by looking at the Boolean class. So bool is a class that's built in to Python and that supports Boolean values. Bool is actually a subclass of int. So we can look at that by looking at this method here is subclass, and we can pass it the classes that we want to look at. So in particular, we're going to want to know, is bool a subclass of int? I need to spell it correctly. And the answer is true. So bool is a subclass of int, which means that bool inherits all the properties and methods of integers and then adds its own as well. It adds a few, like for example, and, or, XOR, and so on. So we also have built-in values. I mean, here's this true here, right? True is actually a built-in value. It's a built-in object, a built-in instance of bool of Python. And so is false. And there are singleton objects, which means that throughout the lifetime of our program, the memory location where true and false live will never change. It will always stay the same. So it's very similar to what we saw with singleton objects like none or like interned strings in an earlier section. So we can take a look at, for example, the type of true. And we'll look at the ID of true as well. And we're also going to look at the integer value of true, because since a Boolean is an instance of int, it has an associated integer value. So let's take a look at those three. So as we can see, the type of true is bool. This is the memory address of true. And this is the integer value that corresponds to true. So true and 1 are very much interrelated. We can do the same thing with false. So we can look at the type of false, we can look at the ID of false, and we can look at the integer value of false. And there we go. So false is a bool type. The memory address of false is some memory address, which of course is different than true. And the integer value that's associated with false is 0. Now we can look at, let's say, the result of a Boolean expression. Let's say 3 is less than 4, okay? That is going to return a true or false. In this case, it returns true. Now we can look at the ID. Well, first of all, let's look at the type of 3 less than 4. That's a bool, right? That's what we expect. Those comparison expressions return a Boolean value. But if we look at the ID of 3 less than 4, you'll notice that that ID here is the same as the ID over here. It's the same memory address. It's the same object. So what that means is that we can compare to Boolean values using either the equality operator, the equals, or the is operator, which is the identity operator. So it doesn't matter which one we use in this case because true and false are singletons. So for example, what I mean by that is we can look and say, we can either say 3 is less than 4 equals true. Obviously, that's kind of silly doing that, but anyway, let's try it. And that returns true because true is equal to true. But just as well, we could say this, 3 less than 4 is true. That will also return true. And this is the same way we might test for none, for example. We might say none is false. And none is indeed false. And we'll get to what that is later on. So we have that, and true and false are essentially just singleton classes. So we can use either is or equals. It doesn't matter. That's safe to do in either case. And it's not like one really performs better than the other. It's pretty much identical. Now, one other thing that we pointed out in the lecture was something like this. So 1 equals 2 equals false. Okay. So this code, what it's doing is first evaluating what's inside this parentheses, precedence. So 1 equals 2, well, that is false. And is false equal to false? Yeah, absolutely. That is correct. We could have rewritten it this way. That would be the same thing. False is false. I'll leave it back as equals. Now, one thing I want to point out is doing this will not work the same way. We get false for a result. And we'll get into this operator chain in a later video, in an upcoming video on Booleans. But for now, just be careful, right? What's happening here is that it's not actually evaluating this, nor is it even evaluating 2 equals false equals 1. It's doing something else. It's actually doing 1 equals 2 and 2 equals false. That's actually what it's doing. But we'll discuss that in a lot more detail in an upcoming video. So be careful with chains, but that's okay. We'll deal with it later. All right, so the underlying integer values, let's get back to that a little bit, of true and false, are 1 and 0 respectively. So because of polymorphism, really true and 1 and false and 0 kind of behave in similar ways. True can either be a Boolean in that context, or it can be an int in another context. And what I mean by that is, for example, let's say we take 1 plus true. Well, here we're doing addition, and true, well, true is also 1, right? It's a little bit like a chameleon. It can be true or it can be 1. In this case, it's 1. So 1 plus 1 is 2. Right? And we say the same thing, like 100 times false. Well, false is 0. So 100 times 0 is going to be 0. In fact, we can even do things like this, true greater than false. Now, I'm not sure that I would ever write code like that, but that will work. Since 1 is greater than 0, that is actually technically true. We also have even weirder things. We can take maybe true plus true plus true, and we can mod this with 2. So really what's happening here is that we have 3 mod 2. And indeed, we get 1 back. You can even do negative true, as we saw in the slides. We get negative 1 back. So true and false can behave as Booleans, or they can behave as integers. Because remember, at the end of the day, true and false are in fact integers. They're just more specialized integers. They have a few more things that we can do with Booleans, like ands and ors. So we can say true and false, right? That's defined, or true or false. Got it. Type right, true or false, okay? So we have that. Now, lastly, what I want to talk about is going from an int to a Boolean. So we can certainly do something like this, bool 0, so we can pass in 0, and it's going to return false. And same thing with bool 1, that's going to return true. So 0 will map back to false, 1 will map back to true, and of course int of true, as we saw, maps to 1, and int of false maps to 0. But what's happening here, it's a little subtle, but we have a number, an integer, and we're passing that to the Boolean constructor. Now remember the Boolean constructor, what we said is that the Boolean constructor will return true if what's passed in is true. Well, we didn't pass true in here, right? We didn't do bool of true. That's true as well, and that's exactly what we would expect. Same thing with bool of false. We would expect that to return false because that's what the constructor does. So how did we go from 0 to false and from 1 to true? Well, we'll get into the details of that in the next video. But for now, let me also show you that bool of, let's say, 100, that's also true. Bool of -1, that's also true. The only time when we will get false is when we use 0. And so there's this kind of rule, and we'll explain why it works and how it works in the next video. But it basically says any number other than 0 is going to evaluate to true. It's going to have an associated truth value, and that truth value will be true. And the only time when it's false is when the value is 0. We're not really converting an int to a bool. We are looking at the truthiness or the truth value of a number, and that is what we use then to generate this bool. All right, thanks for watching, and I'll see you in the next video.